Hi everyone, so this is part 2 of day 6 tree diagrams. Okay, so here's the third example. It says 60% of a company's sales representatives have completed training seminars. So we have 60% of the reps have been trained. So that must mean that 40% have not been trained. Okay, because again, either you're trained or you're not trained. So that should add to 1. Now, of these, it says 80% have had an increase in sales. So of the trained people. So that means that 2% of the trained people must have no increase because, again, either you have an increase or you don't. Now, we don't know anything about the untrained or the not trained people with their increase and their no increase. Okay, so here's the question. It says, find the probability of increased sales given the person has not been trained. Okay, so we're actually trying to find X right here. An increase without training. Okay, so all we know is that 56% of the representatives have had an increase. So increase, that means the trained people with an increase, or the untrained or the not trained people increase. If you add those up, you get 56%. So again, trained and increase, or is plus, untrained with an increase, you should get 56%. So if you solve this, you get 0.2. So that means that 20% of the untrained people will see an increase. Okay, last example, little conditional probability. It says the probability of P given D, that's the probability that a person, it's coming back, there you go, probability that a person with, given that they have a disease, will test positive. That's this, is 99%. So given you have a disease, the test that tests positive, meaning the test says, yes, you have a disease, will be 99%. Okay, but again, there are false negatives and false positives. A false negative is where they say, hey, you have the disease, but, I'm sorry, you do not have the disease. Okay. Here, let me write it down. A false negative. That means the probability that you have the disease given the test is negative. Okay? Probability, have disease, given negative. Okay? And then probability of H given P, that's a false positive, or the probability that you are healthy given the test is positive. Okay, so again, false. All right, so we're going to do a couple examples. What's the probability of a negative test? Well, again, it helps to take a look here at our tree diagram. Notice if this is 0.02, this must be 0.98 because, again, they must add to 1. Either you have a disease or you don't. Over here, either you test positive or you test negative. So these two numbers must add to 1. And again, either you test positive or negative, so this number must be 0.03. Okay, and if you multiply 0.02 times 0.99, 0.02 times 0.01, 0.98 times 0.03, and 0.98 times 0.97. There you go. And this actually was 0.9506. Very good. Okay, so now we have our tree diagram. What's the probability of negative? Well, negative would be a disease negative or a healthy negative. So if you add those up, you get 0.9508. Over here, what's the probability that you're healthy and you get a negative result? So that's 0.9506 because that's 0.98 times 0.97, which is 0.9506. Over here, given that you got a negative result, what's the probability that you're healthy? So that's the probability of healthy and negative divided by the probability of negative, because again, we had our formula for conditional probability from our last unit. There it is. Okay, so healthy and negative, divided by negative, any old negative. So if you divide that, you get 0.9999. Okay, over here, what's the probability that given that it's negative, the test is negative, you really do have a disease? Okay, so probability of disease and negative divided by the probability of any old negative. So that's disease and negative divided by any old negative, which is 0.0002. Okay, so what is the difference between these two things? Well, the probability of P, that means that a person, given they have a disease, they have the disease. The probability that they test positive. Probability of D given P is given that the test is positive, what is the probability that the person has a disease? Okay, great job, everybody.